Today we are going to talk about acids and bases. Firstly, you need to know what is an acid and you need to know what is the base. So our acids and bases have been defined using two theories. Firstly, we're going to use the Arrhenius theory. So Arrhenius, when he defined his base, his um, acid. Arrhenius said an acid is a substance that produces an H plus ion, or you can say hydronium ion, when it dissolves in water. Okay, so this Arrhenius acid. So if you can see, this substance is limited to a certain medium, of which is water. Okay, now let us find the Arrhenius base. Okay, so Arrhenius base is substance is a substance that produces OH ion in water. So an Arrhenius base is a substance that produces a hydronium ion in water. So an alternative definition of an acid, now it will be according to Bronsted-Lowry theory. So Lowry-Bronsted said an acid is a proton donor and a base is a proton acceptor. Okay, so if we can just compare the two definitions, we can clearly see that the Lowry-Bronsted theory is much broader, doesn't limit our substances to a certain medium like the Arrhenius theory, of which it's limited to aqueous solutions or solutions in water. Now, okay, so we need to look at other terminologies. For example, you need to also know what is a strong acid and what is a strong base. Okay, I think I'll wrap this for the sake of space. Okay, when we talk about a strong acid, we talk about a compound or a substance that completely um, I mean that completely ionizes in water. Okay, so what is an example of a strong acid? We can make an example of the hydrochloric acid. Another example, it can be H2SO4 or nitric acid. Okay, Now, what is a strong base? Okay. Strong base is more or less related to the strong acid. A strong base is a substance. A substance that completely I need to fix here. Okay. Completely dissociate in water. So a strong base is a substance that completely dissociates when dissolved in water. So meaning that we talk about the substance that whenever it dissolves in water, it forms complete ions. Okay. So that means a strong base or a strong acid, they are capable of conducting electricity because they form ions. So other terminologies that are relevant to this topic, you need to know what is an endpoint, what is an equivalence point, you need to know what is a hydrolysis. You also need to define dissociation and ionization. Okay, you need to know the difference of the two. So when we talk about an ionization, we talk about the breaking up of the molecules into charged components. Remember, molecules happens only when we have a covalent bond. Equivalent, okay, meaning it's a bond between two non-metals, right? And then when we talk about dissociations, we talk about ionic compounds. Ionic, yes. This N is not there. We talk about ionic compounds, meaning two two opposite ions were together. Now they start to dissolve and separate in water. Okay, fine. Um, Now let's get to the real part of this topic. Alright, we just explained what is an acid and I have given you examples of an acid. Now we need to know what is a conjugate acid base pair. Right. When we talk about a conjugate acid base pair, I will give you an example of a reaction. Let's say NH4, NH3 is added to water, H2O, to form NH4 plus OH minus, all in aqueous solutions. Okay, so as you can see on the left hand side, all the particles or all molecules were uncharged, and ammonia gained a proton or a hydrogen atom to form our ammonium atom here, molecule here. Then it also formed a hydroxide ion there. Okay, now when you talk about an acid base pair or a conjugate acid base pair, we talk about the compounds that differ with an H plus. Okay, so the square brackets indicate our conjugate acid base pairs. So which one is our acid, which one is our base? Now let us look at this reaction. Did ammonia lose or gain? So when we come to this side, we can see that the number of hydrogen, um, we can see that the number of hydrogen removed from 3 to 4, meaning that it's a proton acceptor. So this one becomes the base, and this one becomes the conjugate acid. All right. Now this one became the proton donor because it moved from 2 to 1. So this is our acid, and then this is our conjugate base. So this is how we make our conjugate acid base pairs. All right. So yeah, so if you can check here, the difference between this molecule and it's a conjugate acid, it's an H plus ion. It's an H plus. Okay, let me increase this. So even this pair, the only differ with an H plus. Alright, so I will create another equation. So now let's talk about two water molecules, H2O, of which they react to form H3O plus plus OH minus. Alright, so can you pause the video and try to pair our conjugate acid base pairs? Okay, so if you pair, since these two molecules are the same, you can take either one of these. Alright, so this will form a conjugate acid base pair, even this will form our conjugate acid base pair. So which one, well, if you can check here, we have an increase in the number of hydrogen atoms. So meaning this one acted as a base because it accepted a proton to increasing our hydrogen atoms. So this is a base, it acts as a base, and this is its conjugate acid. So this becomes an acid, and this becomes its conjugate base. So now when we check, or when we see water acted as both a base and an acid. So there is a special term for this kind of molecules. We call it an ampholite. So you also need to know how to explain or how to define an ampholite. It's M4 light. Please do not mind my handwriting. This is a P. So an ampholite is a substance that can act as either a base or an acid. So this is a perfect example of an ampholite. You also need to know that when you go to the exam. Okay. Okay. Now we have this scenario over here. We are given a sulfuric acid of concentration 6 mole per decimeter cube. All right, as per equation given here. Now they said the fizzing due to the formation of carbon dioxide stops after the learner has added 27 grams of sodium hydrogen carbonate to the spilled acid. Okay, now our question says calculate the volume of sulfuric acid that spilled. Assume that all the sodium hydrogen carbonate react with all the acid. Okay guys, so now the information given, we have the concentration of the acid, we also have the mass of the hydrogen carbonate spilled. Okay, so what is our first step? The formula that we need to use here is the formula N is equals to M over bigger M. This is for mass, this is for molar mass. But which values are we going to use? We need to use the values of the base, because we use the base to neutralize the split acid, and the base is the most information given. Okay, so now the formula of our base is it's this one. Okay, so we have Na, of which it has the mass of 23. We have H, of which it has the mass of 1. We have carbon, which is 12. We have oxygen, which is close to 16. Now N is equals to 27 divided by the mass, of which we have 23 plus 1 plus 12 plus 3 into 16. Okay, so here we have 27 over 84, which is equals to, let me punch it, as 27 divided by 84. We have 0, 0.32, 0.32, that is mole. Okay, so now we have gotten our number of moles of the base. Now the next step is to calculate the number of moles of the acid. So now I'm going to use a red pen and a rubber to, I'm sorry about that, a rubber to rub the information that I don't actually need. Okay, so let me use my red pen. So according to the balanced equation, the ratio of this is 1:2. That is the ratio of which they react. So one of this is equals to 2 of that. Okay, so if we want the number of moles of sulfuric acid, we can see that 1 is half of 2, right? So N of H2S04 is equals to 1 over 2 of 0, 0.32, of which it's going to give me 0.16 mole. So now we have the number of moles of our acid. We can actually calculate the volume of the sulfuric acid that was spilled. Okay, so we know that concentration C is equals to N over V. Okay, we were given the concentration of the acid, and we know the number of moles of the acid. So 6 is equals to 0.16 divided by V. So we can interchange the V and the 6. So V is equals to 0.16 divided by 6. Then we get that V is equals to 0.0 3 decimeter cubed. So this is not exactly 0,03, it's 0,026. This value here is rounded off. Okay, so this is actually our final answer, because it said calculate the volume of sulfuric acid that was spilled. So this was a February-March 2015 examination paper for grade 12 metric. It was worth 6 marks. Okay, now the follow-up question says the learner now dilute some of the 6 mole per decimeter cube sulfuric acid solution into the flask to a 0,1 mole per decimeter cube acid. And the question says calculate the volume of the 6 mole per decimeter cube sulfuric acid solution needed to prepare 1 decimeter cube of dilute acid. Okay, so what do we know about dilution, guys? When you dilute a content, for example, if you have a squash juice inside a 1 liter container, then it's sweet enough, then you add water. Now we have a 2 liter container. The concentration of the squash changed, not the concentration but the quantity of the juice. Did it change? The answer will be no, you didn't change the amount of juice that is inside. Okay, the answer will be no, you didn't change the quantity of the juice inside, you just increased the volume of the juice. Okay, so since the quantity of the juice didn't change, that means the number of moles remains constant in the 2 containers. Okay, so now what do? We can say N of the acid initial is equals to N of the acid final. Okay, so what number of moles did we have initial? So the number of moles that we had initial was 6 multiplied by the volume of the acid initial, which is equals to the number of moles that we have final. It's given there, so we are going to have 0,1 multiplied by 1. Okay, so now since we have all values, we can calculate for the volume of the acid. So V of the acid initial is equals to 0,01 multiplied by 1 divided by 6. So our final answer will be 0,02 decimeter cube. Okay, so if you are wondering how did I get this, so N is equals to CV. Okay, from this formula of C is equals to N over V, I cross multiplied so that N is equals to CV, and we are given the concentration here and we are also given the volume here. So these are the values. 6 was given initially as per the previous question, and it's also here. Alright, so this question was only worth 2 marks because it's a follow-up question and it has less steps. Okay, So now during a titration, 25 centimeter cube of the 0.1 mole per decimeter cube sulfuric acid solution is added to an aluminium flask and titrated with a 0.1 mole per decimeter cube sodium hydroxide solution. So now the learner uses promothermal blue as an indicator. What is the purpose of the indicator? Okay guys, the purpose of the indicator is to show the endpoint. This is a keyword and point of titration. Of titration. Okay, remember I once highlighted what is an endpoint. Yeah? So the definition of an endpoint you need to know is endpoint. It is the point where an indicator changes color. So our indicator in this state is a promothermal blue. So the solution needs to change color to the color of this indicator so that we can actually see that we have reached an endpoint. Okay.